You're standing on Earth, gazing at the night sky, when a faint, ethereal object streaks across at breathtaking speed. In the blink of an eye, it vanishes. Not an ordinary meteor, but an interstellar visitor from distant stars. Could it carry secrets of alien life? Or is it merely a wandering fragment from billions of years ago? How do these objects navigate through our solar system, and where do they come from? Let's explore.
Out there, in the cold void between the stars, countless trillions of objects drift freely. They belong to no star, they follow no orbit, they wander between the galaxies. And yet humanity has detected only 3 such objects passing through our solar system. The first visitor was Oumuamua, discovered on October 19, 2017, by the Pan-STARRS-1 telescope in Hawaii. This peculiar object, roughly 400 meters long, had an elongated cigar-like shape and a dark red hue, likely from prolonged exposure to cosmic radiation. It hurtled past the Sun at 26 kilometers per second, following a hyperbolic orbit, a clear sign it didn't belong to our solar system, but came from interstellar space. Upon its discovery, some speculated it was an alien probe, perhaps equipped with a solar sail. But scientists dismissed this due to a lack of evidence. Instead, they propose Oumuamua is debris from another star system, possibly a block of frozen nitrogen or a massive dust clump ejected during planetary formation billions of years ago. Not long after, 2 more interstellar visitors appeared, and this time they were clearly comets. In 2019, 2I Borisov was discovered, a radiant sphere of gas containing cyanogen and carbon, chemical compositions foreign to comets in our solar system. 2 images, captured by NASA's Hubble Space Telescope, show the comet near a background galaxy on November 16, 2019, and after its closest approach to the Sun, perihelion, on December 9th of the same year. In July 2025, the Atlas system in Chile detected 3I Atlas, also known as C2025N1, an icy comet approximately 1 kilometer in diameter. Its tail, strangely oriented toward the Sun, releases dust at a slow rate of about 1 meter per second. Professor Avi Loeb, a renowned astrophysicist from Harvard University, made a controversial claim. 3I Atlas may not be a comet, but an advanced spacecraft sent by an extraterrestrial civilization. Some other experts, citing its massive size and unusual behavior, hypothesize that 3I Atlas could be an artificial object dispatched to observe or even attack our solar system. Meanwhile, NASA scientists argue that these are merely natural fragments from other star systems, though they do not rule out the possibility that they could carry the seeds of life, opening a window to exploring exoplanets. Regardless of its nature, 3I Atlas continues to puzzle scientists with strange images captured during the lunar eclipse on September 7, 2025, revealing a striking green glow, a surprising color shift compared to earlier observations. 3I Atlas will reach its closest point to the Sun around October 30, 2025, at a distance of about 1.4 astronomical units, just inside Mars's orbit. The comet will reappear on the other side of the Sun in early December 2025, allowing for further observations. So where do these cosmic drifters come from? The short answer, everywhere in the Milky Way. Our galaxy is like a cosmic junkyard. On average, each star system ejects about 10 quadrillion fragments, dust from planetary formation, rocks flung out by orbital rearrangements, or ice pulled away by the gravity of passing stars. These fragments form millions of tangled streams, weaving through the galaxy like forgotten ribbons. Tracing the origin of a single object is difficult, as factors like spiral arms, molecular clouds, and stellar clusters scramble their paths over millions of years. For Oumuamua, scientists can only estimate it came from one of millions of stars within a 3,000 light-year radius. But if we detect hundreds of objects, we might identify siblings, pairs from the same star system, allowing us to pinpoint their exact origins. Discovering just 3 interstellar objects may seem limited, but the near future promises a revolution. Right now, about 60 interstellar objects may be lurking within Jupiter's orbit, with another 8 settled long-term in the Oort cloud. Some odd asteroids or comets in our solar system might be disguised interlopers. These objects are often small and dim, only detectable when they pass close to Earth. Fortunately, advanced surveys like the Vera Rubin Observatory, which began operations in 2025, and NASA's Surveyor set to launch in 2027, will transform the hunt. Designed to detect asteroids, they could uncover up to 70 interstellar objects annually. However, the actual number depends on their reflectivity, a factor still unclear. Even so, each discovery is a treasure trove, offering data on shape, chemical composition, and the mechanisms that ejected them from their home systems. Studying Oumuamua, 2I Borisov, and 3I Atlas goes beyond pinpointing origins. They hold profound significance for planetary science, opening windows into how planets form, rearrange their orbits, and stabilize across galactic star systems. Their shapes and chemistry reveal stories of their parent systems, from their initial positions to the reasons for their ejection. For example, Oumuamua shows non-gravitational motion, possibly from outgassing like a comet, while Borisov and Atlas carry molecules like cyanogen, indicating ice sublimation under solar heat. These objects may also seed new planets. A core like Oumuamua could attract gas and dust in a protoplanetary disk, laying the foundation for new worlds. Some scientists suggest this is a common mechanism for planet formation. Moreover, they might explain mysterious phenomena like fast radio bursts, possibly triggered by collisions with neutron stars. Even Earth is struck by an interstellar object every 60 years, invisible cosmic fireworks in our skies. Looking further, intercepting an interstellar object is our best shot at exploring another star system in the near future. A mission to Alpha Centauri would take thousands of years, but with an interstellar object, we could study debris from a system thousands of times farther, within decades. Proposals include alert probes launch upon detection, or small craft parked around the Sun, accelerating to 100,000 kilometers per hour to sample a comet's tail, touch its surface, or land and collect samples. The European Space Agency's Comet Interceptor, set to launch in 2029, targets regular comets, but could pivot if an interstellar object crosses its path at the right time. Solar sail technology, like the Planetary Society's light sail, has proven the ability to propel nimble craft, paving the way for such missions. Astronomer Bryce Bolin from NASA notes that theories about interstellar objects often differ from reality. Determining their origins is challenging due to the galaxy's chaotic nature, with molecular clouds disrupting orbits over millions of years. However, with advanced surveys like Vera Rubin and Surveyor, we will soon detect more such objects, shedding light not only on their origins, but also on the processes of planet formation across the Milky Way. In the context of humanity's expanding ability to observe the universe, interstellar visitors like Oumuamua, 2I Borisov, and 3I Atlas play a crucial role. They not only deepen our understanding of the origins and diversity of planetary systems, but also raise intriguing questions about the existence of life beyond Earth. However, scientists emphasize that all conclusions must be grounded in concrete observational evidence rather than speculative hypotheses. One day we will intercept and directly explore these objects, tasting the ice from distant worlds. Until then, let us gaze at the sky. The stars are whispering secrets through each wandering visitor.